Everyone, Math 103. This is section 6.3, adding and subtracting rational expressions. So we've got two objectives today. First one is to add and subtract fractions with the same denominator. And then we're going to move on to adding and subtracting fractions with different denominators. And when we do that, we're going to go back to what we did in section 6.2, which is find a common denominator, and then rewrite our fractions with that common denominator. And once we do that, we're going to be able to add and subtract them together. But let's start with the same denominator. So we got 2x squared y as the common denominator. So all we have to do here, if you look at the procedure, is add or subtract the numerators, and we'll leave the denominators exactly the same. So that gives us 8 over 2x squared y. Always when to get done adding or subtracting, we have to look for opportunities to simplify. So there's a couple of different ways you can think about simplifying this. We can either divide both the numerator and denominator by 2, and that gives us 4 over x squared y. So that's one way to do it. Or you can write it like this. We're going to write 8 as 2 times 4 over 2x squared y, right? So I just factored the top and then cancel the 2's, and you get the same result. Your turn, number 1. So you already got a common denominator, 3ab. We're going to add the numerators. That gives us 18 over 3ab. Then I can write 18 as 3 times 6 over 3ab. Now we can cancel the 3's, and we get 6 over ab. In this next example, we've got a factorable trinomial. As our common denominator. And so once we get the simplification process, we're going to factor that and look for ways to simplify. So let's combine the tops first. So we got 7x minus 6x, that's x, and negative 4 minus 1, it's minus 5. So x minus 5 is what we get when we combine the numerators. Denominator stays the same. Right now I'm going to factor the denominator. And that factors into x minus 5 times x plus 3. Now I've got matching binomials on top and the bottom, so we'll cancel those. This remains in the denominator, 1 over x plus 3. Your turn, number 2. You have to be careful when subtracting, especially if we get any negatives over here. But fortunately in this case we have all positive values, so 3 minus 2 is 1, so single x. And then 7 minus 5 is 2, so we get x plus 2 on top. On the bottom we're going to factor, and I'll do that in the next step. Right now we'll factor the denominator. And that factors into x minus 5 times x plus 2. Now we've got to match for the binomials. We'll cancel those, so we get 1 over x minus 5. Right, so now we're going to add or subtract expressions with different denominators. So to review a little bit from yesterday, our last class, we're going to find the least common multiple of the denominators of the fractions. Then we're going to transform each fraction to have that denominator. And then we'll do what we did here. Combine them, and then simplify if possible. So first example, we've got just numbers. So we do 5 over 18 plus 7 over 24. So first thing we can do is list the multiples of 18 and 24. When we do that, we find that the first match is 72. So 72 is the least common multiple of 18 and 24. All right, now, one trick you can do with numbers to get the common denominator is multiply by how many, just count the multiples until we get to the match, 1, 2, 3, 4. So it's the fourth multiple, so we'll multiply this by 4 over 4. And we get 20 over 72. Now we'll do the same thing for 24. All right, we got 7 over 24. And we're going to multiply by 1, 2, 3, the third multiple, so that is 3 over 3. So we get 21 over 72. All right, so there's our two new fractions. Now we're going to combine those. So we got 20 over 72 plus 21 over 72. And that gives us 41 over 72. And since that fraction cannot be simplified, we are done. Your turn, number 3. So there's our multiples of 20 and 16. Finally got a least common multiple of 80. Now we're going to transform 7 over 20. And that is the 1, 2, 3, fourth multiple. So multiply this by 4 over 4 and get 28 over 80. And for the second fraction, we got 16, we got 3 over 16. And we'll multiply that by 1, 2, 3, 4. That's the fifth multiple. So we'll multiply by 5 over 5 to get 15 over 80. So there's our two new fractions. So 28 over 80 plus 15 over 80 gives us 43 over 80. And that fraction cannot be simplified. All right, now we're going to start introducing some variables. 2 over x plus 3 over y. Now looking at our two denominators, we have two distinct bases, x and y. They're both to the first power, so just multiply them together and we get an LCD of x times y. All right, this one is missing the y, so we'll multiply the first fraction by y over y. And this fraction is missing the x, so we're going to multiply that fraction by x over x. So that gives us 2y over xy plus 3x over xy. And then finally, we'll combine them together into one fraction. So it gives us 2y plus 3x over xy. And that brings us to your turn, number 4. So the LCD, we're going to look at the coefficients. We have 2 over here and 1 over here. Least common multiple of 2 and 1 is 2. So our new coefficient is 2. We have 2 distinct bases, x and y. They're both to the first power, so the LCD is 2xy. Now the first fraction here, we have the 2 and the x. We're missing the y. So we're going to multiply this one by y over y. So 5 over 2x times y over y is 5y over 2xy. And the second fraction, we've got the y, but we're missing 2 and x. So we're going to multiply by 2x over 2x. And for that fraction, we get 14x over 2xy. Now we've got 2 fractions of the same denominator. Now we can do this operation. There's no way to simplify that, so our final answer is 5y plus 14x over 2xy. All right, now we've got a little more complex denominator. For the next example, we've got 2x over 6y squared. All right, starting to introduce some exponents here. 7 over 8, x to the third, y. So first step, find the LCD. Let's start with the numbers, 6 and 8. List the multiples, 6, 12, 18, 24. And for 8, we got 8, 16, 24. So 24 is the least common multiple of 6 and 8. So we know our LCD. Start with 24. Now let's look at the unique bases. We have x. No x's over here, just one here, so we'll use that one. X to the third power. Now with the y's, take the largest exponent between 1 and 2, that's 2, so the LCD is 24, x to the third power, y squared. All right, now let's find our multipliers. We're going to multiply these fractions by. You can either use the what's missing approach or the division approach. Let's try taking the LCD and divide it by 6y squared. 24 divided by 6 is 4, so we're going to multiply by 4. X to the third divided by 1, x to the third. And then we got y squared divided by y squared, those cancel. So we're going to multiply this fraction by 4x to the third over itself. Multiplying straight across, we get 8, x to the fourth on top, divided by 24, x to the third, y squared. All right, there's one of our fractions. Second fraction, 7 over 8, x to the third, y. Oops, we're going to multiply here. Take the LCD, divide by the denominator. 24 divided by 8 is 3. X to the third over x to the third, those cancel. Y squared over y is y. So we're going to multiply by 3y over 3y. That gives us 21y over 24, x to the third, y squared. All right, there's our 2 fractions with the same denominators. Make sure you check when you're done. If you get the same denominators, that's a good indication you're doing it right. Now we're going to add these 2 things together. All right, add the numerators, 8x to the fourth plus 21y, all over 24, x to the third, y squared. And that brings us to your turn, number 5. So we're going to start off by finding the least common denominator. Start with the numbers 8 and 12. And the least common multiple of those two numbers is 24. So the LCD will start with 24. Now let's look at the bases. X to the fourth and x squared takes the largest exponent, x to the fourth. Y and y squared, larger exponent is 2. So our LCD is 24, x to the fourth, y squared. Let's transform the first fraction. All right, now we'll take our LCD, divide by the denominator. 24 divided by 8 is 3. X to the fourth over x to the fourth, those cancel. Y squared over y, we're multiplying by 3y. So we get 9y squared on top and 24, x to the fourth, y squared on the bottom. Next fraction, 5x to the third over 12x squared y squared. All right, what are we going to multiply by? 24 divided by 12 is 2. X to the fourth over x squared is x squared. Y squared divided by y squared, those cancel. So we're multiplying by 2x squared over 2x squared. All right, multiplying straight across, we got 10x to the fifth power. And finally combine them. We're going to add together those numerators. That gives us 9y squared plus 10x to the fifth power over 24 x to the fourth y squared. Now some of these expressions are going to have binomials in the numerator. Once we start transforming these fractions, you've got to remember to distribute into that binomial. So we're going to find the LCD. We have only one base, x bonus 1, so we know we're going to have an x in there. The least common multiple of 2 and 5 is 10, so that makes the LCD 10x. So that means we have to multiply the first fraction by 5 over 5, and that will give us 10x in the denominator. So 5 over 5 times 3x minus 2 over 2x. Now we're going to distribute 5 into this binomial. 5 times 3 is 15, so that is 15x. 5 times 2 is 10, so 5x minus 10 over 10x. Second fraction, 2x minus 6 over 5x. To get 10x, we need to multiply 5x by 2. So we're going to multiply this one by 2 over 2. All right, now we're distributing 2 into this fraction. That gives us 4x minus 12 over 10x. And now we're ready to subtract the fractions. So the first one was this one, so 15x minus 10 over 10x minus 4x minus 12 over 10x. Now we have to be very careful when subtracting, because we've got a negative over here, so we're going to be subtracting a negative. So first off, let's do the x terms. So 15x minus 4x, that's 11x. And then negative 10 minus negative 12, that's the same as negative 10 plus 12, so that's positive 2. So 11x plus 2 over our common denominator, which is 10x. Your turn, number 6. So just like the example, if you just got a single x in the denominator, so we know our LCD is going to have that single x in it. Right now we need to find the least common multiple of 4 and 7. And that is 28. So our LCD is going to be 28x. So how do I turn 4x into 28x? We're going to multiply by 7 over 7. Now distribute 7 into the binomial. That gives us 28x minus 21 over 28x. Right, now we'll do the second fraction. It's minus 5 over 7x. We need to turn 7x into 28x. So we're going to multiply by 4 over 4. Distributing 4 into the binomial, that is 4x minus 20 over 28x. All right, now we can subtract it. So subtracting the x terms, 28x minus 4x is 24x. And negative 21 minus negative 20 is the same as negative 21 plus 20. So that's minus 1 over a common denominator, which is 28x. Next example, we've got binomials in the denominator. Four x over 2x minus 1 minus 5 over x minus 6. And I've got two non-matching binomials. That means the LCD is going to be their product. So the LCD is 2x minus 1 times x minus 6. So that means, in this case, all we have to do is multiply these fractions by the other fraction's denominator over itself. So that'll be 4x over 2x minus 1 times x minus 6 over x minus 6. Minus, and then on this side, we got 5 over x minus 6 times 2x minus 1 over 2x minus 1. Now we're going to have to distribute into the numerator. The denominator, just leave it in factored form. There's absolutely no reason to FOIL that out. In fact, it actually makes it harder to see if we can simplify the result. So just leave the denominator in factored form. All right, distributing in here, it gives us 4x squared minus 24x over x minus 6 times 2x minus 1. And then over here, distributing the 5 into the binomial, that's 10x minus 5 over x minus 6 times 2x minus 1. Now we can combine the numerators. So we have 4x squared, nothing to combine with over here, but we can combine these x terms. Negative 24x minus 10x is negative 34x. And finally, we've got minus negative 5, that's the same as plus positive 5, so plus 5 on the end, over x minus 6 times 2x minus 1. Your turn, number 7. I'm going to do this one a little bit more concisely. I'm going to go ahead and write to the next step. We know that the LCD is the product of those two binomials. So that is x plus 5 times 2x plus 3. Now we multiply by the other fraction's denominator over itself. So x plus 5 over x plus 5 over here, and then we'll take the 2x plus 3, bring it over here. Now we can multiply. So I'm going to distribute 6x into this binomial, and that is 12x squared plus 18x and now I'll distribute 3 into this binomial, so that is 3x plus 15. And now we can combine like terms. All right, 12x squared, nothing to match with there, so we got 12x squared. Now we've got 18x minus 3x, so that is 15x. And now we're subtracting 15, so minus 15 on the end. Over our common denominator, 2x plus 3 times x plus 5. Now this last set, we're going to need to do some factoring before we can find the least common denominator. So I'm going to start off by factoring the trinomial in this first fraction. And that factors into x minus 3 times x plus 2. So let's look at our binomials and denominators. We've got two unique ones, x plus 2 and x minus 3. So there's your LCD. X plus 2 times x minus 3. All right, this one already has the LCD in the denominator, so we don't have to change that one at all. Only thing you do is multiply this one by the missing piece, x minus 3 over x minus 3. Now we'll distribute 3 into this binomial, so that's 3x minus 9 over our common denominator. And now we can combine these numerators. 2x minus 3x is negative x, and we're subtracting negative 9. So that's the same as adding positive 9. So negative x plus 9 over x minus 3 times x plus 2. You can also write that as 9 minus x if you prefer it that way. Your turn, number 8. Got 2 of them there. So we'll start by factoring the first fraction. Right, this is a perfect square trinomial, and we get x minus 5 squared minus 3 over x minus 5. Now the LCD, we have only one unique binomial, that's x minus 5. And of these two, the larger exponent is 2. So the LCD is x minus 5 squared. So the only part we're missing over here, we only have one x minus 5, and we need 2 of them. So we're going to multiply this by x minus 5 over x minus 5. So that gives us 3x minus 1 over x minus 5 squared minus, now we're going to distribute 3 into this binomial, 3 times x, 3x. 3 times negative 5 is negative 15 over x minus 5 squared. Let's see what we have on top here. We got 3x minus 3x. The x's are gone. -1 minus -15 is the same as -1 plus 15. So that is 14 over x minus 5 squared. All right, part B, 2x over x plus 1 minus 1. All right, this one's a little different. Sometimes that 1 can be a little jarring. We haven't seen a problem like that. But just remember that 1 can be written as anything over itself. So if we want a common denominator of x plus 1, we're going to rewrite that 1 as x plus 1 over x plus 1. All right, now let's combine the numerators. 2x minus x is x minus 1 over our common denominator of x plus 1. X minus 1 over x plus 1. All right, so this is one of the toughest lessons we've seen in this course. A lot going on in each of these problems. So if you get stuck, that tells you something you need to work on. All right, everybody, have a great day.